So how did the planets form? The answer to that is accretion, which is the accumulation of materials to form planets. Let's go through a quick timeline. At the beginning of our solar system, it is believed that a spinning disk, called a solar nebula, formed the Sun. Pieces of the disk begin to clump together around the formed Sun due to gravity. Planetesimals, which are smaller objects with diameters around 1,000 meters, eventually formed. And then, through many years of collision and gravity, protoplanets that were roughly the size of moons came to be. Beyond that, the outer and inner planets formed quite differently, which is why, when you look at all of them, they look so different. Merriam-Webster defines a planet as a large, round object in space that travels around a star. However, NASA defines it much more specifically, with 3 criteria that must be met to be classified as a planet. For one, it must orbit the Sun. Second, it has to be spherical. Third, it must be large enough to pull objects towards itself, or have a strong enough gravitational pull that will force objects to swing past it and catapult into another part of space. What is so cool about the planets is they are all so different. Really quick, I'm going to go over just a few of the facts which makes them so unique. I'll start out with the 4 terrestrial planets, then I'll move out to the gas giants. Mercury is the closest planet to the Sun, and it is the smallest of all 8 planets, being just a little bit bigger than our moon. The temperature on the planet has a large range, which goes from a bitter -280 degrees Fahrenheit to a blistering 800 degrees. A day on Mercury lasts nearly 59 Earth days, and it moves around the Sun completely in 88 Earth days. Venus is the next one out, and it is very similar to Earth in size and in structure. However, its surface is completely toxic and thick, and it traps heat. So much heat, in fact, that it can melt lead. Although there is a cloud of sulfuric droplets that cloud the planet, we do know that it has a solid surface that is heavily cratered and covered in volcanoes. Earth is the planet we call home. It is the 3rd planet from the Sun, and the only planet in our whole solar system that with just the right factors that lead us to support life, and for that we can all be thankful. Mars is the 4th planet from the Sun and the last terrestrial planet. Unlike the planets closer to the Sun, the average temperature on the planet is very cold at a -80 degrees Fahrenheit. Like Venus and Earth, it has many canyons, craters, and volcanoes. In fact, it has the largest volcano in the whole solar system, called Olympus Mons, which is 3 times as tall as Mount Everest. Jupiter is the first of the gas giants, and it is huge. It is the largest planet in the solar system, with a diameter of 140,000 kilometers. That's over 11 times the size of Earth. It also has 67 known moons, and it has the shortest day of all the planets, spinning on its axis once every 9 hours and 55 minutes. Jupiter also is known for the giant red spot, which is a high-pressure storm similar to a hurricane. This is something that has been going on for hundreds of years. It is very easy to see how Saturn can be considered the most beautiful planet in the solar system, behind ours obviously, due to its 7 groups of very bright, distinctive rings. It also has a moon, Titus, that some scientists believe could harbor some sort of life in the future, just maybe not like what we have on Earth. Uranus is the 7th planet from the Sun. It is the coldest planet out of all at a temperature of -371 degrees Fahrenheit, and it is known as the ice giant due to this fact. A year on Uranus lasts a whopping 84 Earth years, and it spins on its axis almost perpendicular to the Sun, something which only happens on Uranus. Neptune is the last planet and the smallest of the gas giants. However, its mass is larger than that of Uranus, even though its size is smaller. Also, in 1989, there was a large storm that lasted 5 years, dubbed the Great Dark Spot. The climate on Neptune is very active, and winds can blow around the planet at an incredible 600 meters per second.
you know how the solar system is arranged, think again, because there just might be a planet X lurking well beyond Neptune. Hey guys, Amy here for D-News. Most of us grew up with 9 planets. Then Pluto became a dwarf planet along with the other Kuiper Belt objects, and the layout of our solar system changed. Now we've got 8 planets and hundreds of dwarf planets. All of these objects orbit the Sun more or less regularly. Their orbits are all slightly elliptical and vary in inclination, but let's call that regular, because there are objects beyond the Kuiper Belt that have extremely irregular orbits, and they're throwing a bit of a wrench in how we imagine the solar system is arranged. Sedna is a dwarf planet that traces a highly elliptical orbit around the Sun. 1 astronomical unit, or AU, is the distance from the Earth to the Sun. Sedna only comes as close as 76 AU to the Sun and goes as far out as 940 AU. And it's got a companion out there, a recently discovered dwarf planet called 2012 VP-113 that only comes as close as 80 AU to the Sun and travels as far away as 452 AU. There are a small handful of other bodies with similarly strange orbits, and the question plaguing astronomers is why? Why are these bodies unlike all the other bodies? They aren't part of a distant debris field. They're too far from Neptune to have their orbits perturbed by Neptune, and they're too far from the Oort cloud. It's possible a passing star pulled them away from the Kuiper Belt at some point. Or it's possible there's a massive planet out there that's not only pulled these objects into their irregular orbits, but that's also keeping them in their strangely distant places. It's far too early to tell. Astronomers will need to make a lot more observations to confirm anything, but studying the irregular orbits of these distant tiny worlds could uncover the existence of a 9th planet, or a 10th planet depending on how you feel about Pluto. The discovery of 2012 VP-113 is adding compelling evidence to this idea. And this isn't even a new way of looking for planets. It's actually how Neptune was discovered. Neptune's orbit was predicted based on irregularities observed in Uranus's orbit. Lo and behold, the planet was there. Irregularities in Neptune's orbit led to the prediction of an even more distant planet X. Pluto was actually found near this predicted planet, but it's too small to really act on Neptune. So could the irregularities in these dwarf planets win